Hi everyone, and welcome to the first of the VELUX webinars as part of World Green Building Week. You've joined us today for a session titled Daylight Visualizer, a simple tool to evaluate the upcoming European standard for daylight in buildings. It's a real pleasure to have so many of you with us today, and we hope that you'll enjoy contributing throughout the session. If you have questions for our speakers, then please do write them directly in the questions box, and we'll pick these up throughout the session. Or if you have comments to share with the wider world, then please do tweet us. Please use the hashtags Better Places for People and World Green Building Week, and say hello to us at WorldGBC and at VELUX. So the structure of our session today will include a short introduction from me, and then we'll be handing straight over to our two speakers in today's session for a brief insight into each of their areas of expertise, before we open up into a wider discussion, including audience Q&A. So to start the introductions, I'm Katrina Brady, Head of Better Places for People at the World Green Building Council. The World Green Building Council are a global network consisting of over 70 national green building councils. Our membership totals around 50,000 individuals and organisations, and we engage our membership around achieving green buildings for everyone, everywhere. Now, Better Places for People is one of the global projects of the World Green Building Council, aimed at increasing the demand and supply of green buildings, which are supportive of the health, well-being and productivity of the people within them. We're really proud to partner with VELUX as a Better Places for People global project sponsor, and are delighted to work together for this series of educational webinars. Now, as part of Better Places for People's work in promoting green buildings with health and well-being co-benefits, we promote a number of features related to the built environment, which help us to make our places and spaces more sustainable. And one of these core features that we discuss is daylight. Now, we all know that daylight is an incredibly important natural resource, given it provides us free heating through solar gain to our buildings and unlimited power through solar energy. And capitalising upon these passive and active uses of daylight are fundamentally important for lowering our carbon emissions and reducing climate change. Daylight is also an integral component of all human and natural life, and access to daylight in buildings has huge health impacts in terms of our psychological well-being and circadian rhythms. Now, European and many global building regulations enforce a minimum level of daylight within a space to be provided by apertures to ensure that spaces are well lit and allowing the occupants to experience these environmental and health benefits. And in today's session, our expert panelists will delve into the forthcoming European regulation around daylight in buildings. So today's session is titled Daylight Visualizer, a simple tool to evaluate the upcoming European standard for daylight in buildings. And I'm delighted to be joined by two experts to help us unpick this very relevant topic. Jens Christoffersen is a senior researcher at the VELUX Group, based in Copenhagen in Denmark. Jens will be speaking to us about the upcoming European standard for daylight in buildings and detailing how we should be setting climatically appropriate daylight factor targets for our buildings. Jens will be followed by Nicholas, who is an architect at the VELUX Group and a daylight expert. Nicholas will introduce us to the VELUX Daylight Visualizer, which is a free 3D modelling tool developed by the VELUX Group. Nicholas will give us a short introductory presentation and then talk us through a live demonstration of the software. Now, on conclusion of the presentations, we'll open up for questions and discussion with the panelists. So please do submit your questions in the chat box throughout the session. So it gives me great pleasure now to hand over to our first speaker in this session. Jens, over to you.
Thank you, Katrina, and good afternoon, everybody. I'm happy to see that so many of you have joined. I'll go briefly through the upcoming European daylight standard, which it has a title, or the name is called EN 17037. And it's I just need to be sure that I'm okay. And what I will focus on is that I will focus on the part which is about data provision in buildings. But I will also briefly touch upon the three other sections we have in the daylight standard. It's something about view, it's a section about sunlight, and it's a section about glare. And to be explained to you, the European standard can be applied to all spaces. So it's both for workplaces, it's dwellings, so commercial and non-commercial buildings. But I will first take you through and to give you some short introduction to what it is all about. The European standard, which will be officially published hopefully before Christmas, it's around that time. It's built up of two blocks, and this is the normal way of building up a standard. It's you have the normative section and you have the informative section. So in the normative section, you have the scope, the terms and definition, and the symbols in the first four sections. And then in section 5, we talk about assessment of daylight in interior spaces. And that's where we talk about the normative description of data provision, view to the outside, sunlight and glare. And this is a place where we have explained what is the methodology about it. Then in the first annex is the recommendations. So we have recommendation for how much data you should provide, what is the content of the view to the outside, when should you be exposed to sunlight, and how to protect yourself from glare. The Annex A give you these recommendations, and then the four next annexes, Annex B, C, D, and E, will give you some more insight how to fulfill those. So that's how the standard has been built up. So to take you through first thing, this is the methodology, which is some, as you can see, it might not seem very different from what you might do today. It still use a data factor, but what you can say is that you do simulation in the normal way, and then you see if you can reach the target data factor. The target data factor is based on an internal illuminance of 300 lux, and then we have defined the external horizontal diffuse illuminance outside at the location of where you are in Europe. So the table at the bottom, you can see I've given 3 cities, Berlin, Paris, and Rome, and all have the same internal illuminance level, but the external illuminance level is based on the climate file at the location, and that's, of course, is a slightly different from location to location, which also give you a slightly different target data factor, or of course, and at the target minimum. To the schematic plane view of a space to the right, you can see the room where we describe how to fulfill the recommendations in this standard. You need to fulfill it by at least have 50% or more of the space to be higher or equal to the target data factor. And then at minimum data factor should be for the whole space, or 95% of the space, because there could be some places where you have some small obstacles, so that will be, you can say, the darkest spot. So what we say is that you need to design with daylight and achieve a target data factor or cross the fraction of the relevant floor area, which in this case for a vertical facade or for a vertical facade one, which is 50%, and then of course also the minimum for across 95% of the area. If you have an opening in a horizontal roof, the target data factor should be across the whole surface, which is the 95%. So as you can see, it's built up by using the internal illuminance level, the climate file of where we have defined or described the median of the outside illuminance level for each location, and this is using the climate file, and then dividing those two together, you will get the percentage, which is a target data factor and target minimum. in the standard, you will have a target table with target daylight factors for all capital cities in Europe. And as you can see on the next slide, you will see then that due to the climate in the different countries, if you take the southern part of Europe, you have brighter skies and more light during the daily hours than you will have in the northern Europe. And that's why you also need, for example, higher targets in northern Europe compared to the southern part of Europe. So this is you can say is a modest enhancement of existing practice where you did the data factor calculations. Now you know you need to reach and look at, for example, the target if you are above or equal to or above the target. So for each country, you will find the targets in the table. So it's business as usual. Just you need to check if your target is above. Just to give you I'll get back to the mouse. Hopefully it works. It doesn't move. Come. Yeah. Just to show you an example, I've taken a simple square room of 4 by 6 meters, where I looked at a window to floor ratio of 1 to 8 for the same and for the same window size. So a window to floor ratio of 1 to 8 gives me a window that is a square of 173 times 173. And if I locate it in the middle of the facade, I can see I have a daily area of a target of 2% or higher in 41% of the room. If I move the same window to the left, which is close to the sidewalls, you can see I have a more uneven distribution of light, and then the daily area, which is the time you need to be above 2%, is then reduced. I can make it as a kind of a door, which reduce it even more, or I can separate or divide the windows in, so I have windows in two sides, where I have a slightly better distribution, but still not enough. But as you can see, for the same window to floor ratio, you can have very different daylight performance and daylight provision in the space. And for this room, it's between 21 and 41% of the calculation point, where you have a target where you are daylight factors above 2. So you can say if the target, which we have, is 50% of the floor area, in this case, the window needs to be increased, or if you are at a more southern location, it might actually support you or fulfill the recommendations in the standards. So a few more, very short, about the view to the outside. What we have is that we have defined minimum targets or minimum recommendation for all categories of daylight, view to the outside, sunlight, and glare. So the minimum recommendations at the level is that you need a horizontal side angle, which try to show on the illustration to the right, where you see a picture of the Eiffel Tower. So it shows you the degree of the horizontal side angle, and it could also be the distance from where you sit to the Eiffel Tower, and it could be also the number of layers you can see in the view to the outside. So for the minimum recommendation, which is the standard, it gives you minimum recommendation. You need to have not the outside distance is not so far, and you need at least the landscape layer to see to be included in the view to the outside from the space you're sitting in. So this gives you some of the recommendation regarding view to the outside. When we talk about sunlight to the sunlight is only a recommendation for exposure to sunlight is only for spaces in a dwelling or in a hospital bedroom, patient room, or in kindergarten, while the view to the outside, the daylight provision, and the glare is I'll repeat myself. The view to the outside and daylight provision is for all spaces. Sunlight is in dwellings and or patient rooms, while glare protection is only in spaces where you do office-like type of work. So what we recommend here and what we have used here is to show you that you need to apply a certain amount of hours between February 1st and March 21st. You need to have a certain amount of hours in at least one of the habitable rooms in your dwelling or a patient room. And the minimum target here is 1.5 hour. So you need to provide at least this kind of possibility for sunlight exposure in a space. It doesn't give you any direction how far in. It just needs to be estimated at the inner part of the side of the wall. So you will be entering the space. And to the end, I'll talk shortly about the glare. We use the daylight glare probability as our metric for estimating glare from windows. And we have 3 levels, but we expect and we use the minimum target where you can see you have an annual daylight glare probability should not exceed 0.45 for at least 5% of the occupation time of the relevant space. And if you don't know how to calculate the GDP, there is in Annex E a host of tables that will give you the values you need to know for this kind of evaluation. So you don't need to do your calculation by yourself. You can use the tables. It will cover 95% of the shading devices on the market in Europe at the time. This table is developed also together with another standard called the EN 14501, which is now also in the process for development. So if there are no further questions, this ends my talk, but feel free to talk and ask questions and I'll join you later on in the discussion after Nicholas take over.
Thanks so much, Jens. That was a great introduction for us all. And personally, I hadn't realized how substantial the differences in external illumination could be in similar parts of the world where they're just cities apart. So yeah, definitely interested to hear more about that in the discussion later. But now let's hand over to Nicholas for more information on the daylight visualizer. Nicholas, over to you.
Thank you, Katrina, and thank you, Jens. Hello, everyone who's joining us for this session. I'm glad to be here, and I will say a few words about our simulation tool and showcase how to use it to evaluate these daylight factor requirements for the upcoming standard. The daylight visualizer, it's a professional tool for daylight simulation. It is both to visualize the appearance of daylight in the room, but also to get some concrete information about the light levels and also to evaluate, say, with performance indicator like a daylight factor in order to validate the performance of your building against, say, standard requirements. In the daylight visualizer, there's 3 types of simulation output. One is to make a luminance simulation, which pretty much mimics what will be the experience with your own eyes. So basically the light output from surfaces, so you can see what is the color and the properties of the surfaces. An illuminance rendering, which is measuring the intensity of the light falling on surfaces, in which case you can see the windows appear black because in daylight visualizer version 2, the windows is a light source, so basically they emit the light and don't receive it. And then you see in the grayscale the intensity of the light on the surfaces. And you can represent those with a false color or isocontour, or to apply some numerical value as a grid overlay over the image. And the last one on the right is the daylight factor, which is presenting here a plan view, and that's usually measured on a work plane height, and it shows you what is the spread of the diffuse light from an overcast sky into the building through a relative measurement, available light inside outside expressed as a percentage, pretty much as it's illustrated here on this simple graphics, where you have a measurement inside of the work plane height, and you do this for basically a multiple position in the room compared to the simultaneous level outside, and that gives you this percentage for daylight factor. So this has been around for a while. You can see the reference from Upkins from 1963, and it could be practiced by hand, so it can also be measured into existing buildings. An example of a daylight factor output here, it's from a kindergarten project, and you can see the shape of the building on the pictures on the left. It's a one-story building with a lot of rooms. It has this wavy roof, and the volume of the rooms is quite dynamic without any flat roofs whatsoever. And it kind of shows here the process that has been through with the architect, where there was an initial design which we evaluated through the software, and then to come to this optimized design at the bottom right. And well, the differences are not major between these two design. It's mainly a replacement and adjustments of the roof window distribution on the roof, and the work with the lining openings, in order to say take a little bit of light from you could say over bright circulation areas and bring them into key zones like the activity gymnastic room, and also the canteen where everybody gathers for lunch. So that's the kind of thing that the software allows you to verify and basically reach a really good optimized results, which would have been hard to do only by the head. Another example here from a residential building project, where you can see again a non-standard shape. So it's possible to evaluate very quickly, say rectangular room you can build within Daylight Visualizer, or you can import building project from a range of 3D CAD programs and have a lot of flexibility over the design. So both paths are possible in the tool. This is a comparison here between rendered image and actual photograph from the realized project in the Sunlight House, which was the house we just saw on the previous slide. I guess you guys can detect which is which, but on the left there is the image from Visualizer, and on the right the photograph. And if you pay attention to the patterns with the highlight of the soft highlight of the diffuse light and the shadows, well, there are so many of the same little details which are present, and that kind of validate the fact that Daylight Visualizer is capable of rendering these aspects of daylight. The difference between the two process you can use when working with the tool, you can either create a 3D model from within the tool itself. This is done very quickly. Once you know how to use the modeler there, you can create a room within 2 to 5 minutes. And this way you can evaluate a very wide range of designs, say in the offices, schools, even of course residential buildings, so on. And for the more complex spaces, so if you have atriums, multi-story buildings, and basically there's no limitation to the complexity of what you can import into Daylight Visualizer. So then you can use, say, Revit, AutoCAD, SketchUp, or some of the other 3D modeler like 3D Max, Rhino, and Cinema 4D. And we support some file format that allows you to import from all of these different platforms. It's of course not always a direct import. It requires you to know how to prepare the model for use in Visualizer. Also, sometimes you need to know exactly how the window glass is modeled in order to assign the correct material in the program and the correct transmittance properties. That will of course affect the daylight, very much affects the daylight levels in your simulations. Some of the limitations I've mentioned for the 3D modeler is that, you know, it's simple building, one-story building, doesn't support curved elements like curved walls and as such. And the 3D importer is that once you import a model in Daylight Visualizer, well, you cannot go and further modify this model by adding new window or changing the walls, etc. So there is a certain workflow considerations here. Now for the, I will give a live example of how to use Daylight Visualizer to calculate the requirements for the European standard. I'm using this school here, which is actually a real project that was renovated. You can see on the top, the image left is the situation before for the schools and the new situation by adding the roof window there. And I've selected well, you can see here the image a little bit, the light atmosphere from the two situations before after. And I've selected, well, that's the overview of the building situation. I've selected 3 classroom. You can see classroom 2 is the same as these volume here. Of course, the external obstruction situation slightly different. Classroom 3 is, well, also this one is the same as classroom 2. Classroom 3 is the same as this volume. And then classroom 1, which is unique in this building. So let's have a look at the process through the application. That's a video I've recorded showing the old process of yeah, rendering this model, and I will talk over. So first of all, at the top, you have a progress bar that shows the different steps of working with a 3D imported model. In this case, under the first step with the scale and units, what you want to do is you want to first verify that the scale of your imported object is correct. In this case, it is. If it's not, you apply a scale factor, and you can also change the units, which is used for working with the model. It's pretty straightforward. Then you have a 3D view, which shows you the model. You can see here I've included environment around, very simple environment with some sort of a fence around the building. Sometimes you want to be more accurate when you have the information available and the time, but it's always recommended to not simulate the building standing alone without any obstruction, because that will be a source of discrepancies, of course, in the evaluation. Under the next step, you have the surfaces, where you have a list of elements. That's the that's what you have created in your model. So you will assign a material type and surface properties to it. So for the walls, I'm using here some standard value grayscale at 50% reflectance. So I set the RGB channel to 0.5. That's a kind of a, you know, a straightforward way to do it when you work with model. You can add specularity, roughness, but in this case, it's not necessary for daylight factor calculation. The ceiling is set to 0.7, the floor to 0.3, following standard value for daylight factor calculation. The glass, there's two material you can use. The window glass is when you have modeled your glass with only one layer of polygon. You assign the transmittance with the RGB transmittance factor. You can differentiate between different transmittance value for the glass by adding more than one type of glass in your model when you have, say, different properties for your windows, so you can differentiate between them. The work plane, which are shown right now, is that there's a zone tag to them. It went a little bit fast. And basically that will make it so that these will return results in the report. The location settings, it's done by giving orientation to the model and then setting the location coordinates. There's a drop down with a list of European, well, actually world capitals. The next step is to define the camera view. So in this case, we want a plan view that's 850 millimeters above the floor. So I'm going to use the blue line there to have a quick look at you know, the floor tab. It's about 200 millimeters, so I set it to 1050 my work plane height. Then I want to use a set area to go and set the calculation area fixed to the building boundaries and not the old model I just imported. That would give a better camera output image as well as a nicer calculation result. In the render tab, you have the choice of simulation type. For daylight factor, you cannot choose a sky condition and time of year because it will not influence the results since this is a relative measurement under overcast sky condition. So you select the render quality, and in this case, we'll use the medium one. When you calculate a very advanced building like this for final calculation, I would use high quality. And when you have even more complex building, then you want to go for custom resolution and say, crank up the resolution of your image above 3000 pixel width and so on. So that will ensure that the simulation results converge. They are defined against the complexity of the model you want to evaluate and how many rooms, etc., is included into it. So first, the program calculates the camera output, which is what we can see here. And you can read the results from this output. But in this case, we have zones, and that will allow us a more detailed analysis of the results, as we will see in a few seconds. So in the output, you can change the mode between isocontour and false color. And in this case, we have these 3 zones that are selected. So now I can review the results for them. If you let the mouse over, you will get this pop-up with the statistics. So here we can see the median value, which is what we're looking for as the target daylight factor, and then the minimum value as well, which is what we're looking for to validate the minimum. In this case, the minimum for work plane 3 is lower, so I can go and say target value to 0.7, and then it will inform me that 99%, the last number, is above set value. You can generate a HTML report with all this information that you can, well, it will save the report on your computer, and you can later on go and also evaluate how much is above a certain value and get the overview of the statistics for each of the work plane you calculated. So here you could enter a different value and say calc, and then you'll see how it influences, well, how much of the work plane is above set value. Very interesting also is the uniformity factor, which I find quite useful when I compare one situation to the other, and even more so in a classroom environment where having a good uniformity of daylight is just a plain good idea. So that was it for the video here. I think I just need to go beyond that. Yeah, so I've collected here the overview of the results calculated for the model before the renovation and then after the renovation. And what we can see is that the classroom 1 is the one that basically wouldn't meet the requirements for the European standard. I think it's interesting and important to remind ourselves that a standard only sets the minimum requirements. So it's interesting to see that before the renovation, actually 2 of the classrooms were we're meeting these requirements with having a median above 2.2 daylight factor, and then more than 95% of the work plane above 0.7. Interesting to look at is, of course, after the renovation, how it increased these levels, and also the uniformity. You can see, for example, classroom 2 go from a uniformity 1 factor of 0.21 to 0.55. So you have a much more uniform use of daylight, so that each student more or less get a similar amount of daylight on the work desk. So that's the kind of tools you're given as a designer here to validate your design, but also to optimize it and make it better. And the Daylight Visualizer online resources, it can be downloaded for free under vis.velux.com, and it's available for both Windows and Mac. It's a program we're still developing, so you should expect some new versions to be released in the months to come. And we have a YouTube channel for video tutorials, so that you can look into with a cup of coffee into how to use a program and have all the guidance needed. And if there's a need for more question, it's always possible to get in touch with us. Thank you.
Great, thanks so much, Nicholas. And I'm sure the audience on this webinar will agree that it's so helpful for us to see the software in action, and it looks very user-friendly.
That was that was intended in the design, yeah, very much.
Well, we now have the opportunity for everybody who is involved in this session to dive in with some questions to our panelists while we've got them here on the line. So thank you to those of you who have either pre-submitted or asked questions in the chat box. And please do continue to do so. I'll be moderating this for the next few minutes of this session. So let's start now with a pre-submitted question for our panelists, taking this a little bit more high level. But one of the problems that we face in temperate climates, most of us dialing in here from Europe, is due, I suppose, in part to the thermal efficiency of modern building materials, is overheating in buildings. Now, overheating is, of course, a particular threat if you have a south or a west-facing space with access to more natural light and the resulting solar gain. But what advice do you have for developers and architects about how to ensure that the daylight requirements are met in their space, but ensure that we don't inadvertently create uncomfortable spaces for the occupant?
It's a very good question. Basically, there are different ways and approach to do so. First of all, having a good knowledge of the climate where you intervene, and consider the window layout in relation to this. Then you want to have some measures for sun control in the climate where it's the most needed. But also, I mean, as we build more and more energy efficient houses, they can get a little bit like like a thermos. So basically what we find is that the natural ventilation in the summer period, and ventilative cooling at night, and dynamic shading operation of windows is a way to without mechanical cooling to ensure that the building remains comfortable. And we have some simulation tool called Energy and Indoor Climate Visualizer, which is similar to Daylight Visualizer and allows you to actually simulate what will be the thermal comfort, the air movement in the house, and the air quality. So there are also simulation tools that you can use to evaluate your buildings and get some different scenarios and then try to select the best one.
Yeah, and just to step in here is that just another thing, one of the things we would like to do, and that's why, so the question is very valid, is that we do have a demonstration project where we try to evaluate and try to see if we are meeting, the requirements for example, for the data provision in the space. What happens to the other indoor climate parameters. And for example, model home we have in France, which is available, and you can see documentation on our website. We easily could see that even though we had very large window and probably beyond what is the minimum recommendations in the daylight standard, you still had reasonable interior temperatures in the summertime. Even if it was extremely hot, you had several degrees lower temperature in the main space based on the way you ventilated by natural ventilation, stack effect, and so on. And of course, using solar shading when it's extremely warm outside. So there are measures to do it, and there are techniques to do it. The one thing is very important to mention is that you should consider that you have enough daylight good daylight inside a space, and maintain that, because there are easy way to, how can I say, reduce the challenge with overheating. For example, with the solar shading, it's much more difficult if you have a dark space to do something about that.
Thank you both. That's great to hear, and probably very useful for our audience to know that you can use the thermal comfort and the daylight visualizer tools hand in hand. So we've had a couple of more technical questions now, which we'll move over to. Firstly, perhaps a question for Nicholas, but please do jump in, Jens, if you'd like. But can you model shadows from the surrounding environment with this software? For example, hills or other buildings?
Yes, very much. If you work with the 3D modeler in Daylight Visualizer, there's under the first step something called custom object that you can use to place outside the building and represent mask of obstruction of different degrees. So basically, it can be sized to a lot of different sizes in order to represent either vegetation, landscape, or building obstruction. And with the 3D importer, you really have full control, so you can come with your the full landscape and details and import this as part of your model. And then you will, since you have a very large model at that time, you want to use a set area to calculate, of course, the daylight for the building and not for the entire map. So that's possible, yes.
Great, thank you. Another technical question, but is it possible to import a weather data file?
The weather data file is not used in Daylight Visualizer, so maybe in the future when we go and do annual climate-based simulation, it will be relevant then. But at this time, with the daylight factor and the kind of luminance and illuminance simulation following the 15 CIE sky definitions, then we don't use this climate file. On the other end, the Energy and Indoor Climate Visualizer uses climatic data, weather files, in order to do these thermal simulation and air movement and so on. And it's possible also to have some basic light calculation in the Energy Indoor Climate Visualizer.
Great, thank you. And another more technical question. Hope this isn't putting you on the spot too much here, but we've got a question saying, does the daylight visualizer's calculation method comply with the Danish requirement in BR18?
Jens, I will let you answer this question.
Thank you, Nicholas. Yes, it does. You can use the daylight visualizer to support the some of the Danish building legislation. So if you use the target data factor for Copenhagen that is in the table, you will reach the 300 lux that is addressed as a target interior luminance levels in the Danish building legislation, which was developed in this year, in 2018. So yes, you can. The full climate-based data modeling is not possible at this moment, but that's something we're looking into.
Great, thank you. And now maybe to go a little bit more high level, but at what stage in the design process would you recommend that developers and architects and consultants start to think about internal daylight within their building?
Very early on in the initial design phase of the building, in order not to have it as a quick fix. Of course, it depends on various factors. If you're a single family homes developer, you have a lot of freedom how you're going to look into the daylight. Whereas if you develop more large-scale projects where urban planning, etc., and then you want to consider it early, because you might be limited, later on the process when the building mass and so on has been drawn. So it depends how much how much requirements attached to it and how much freedom you have in the context. But I will always recommend to work it very early on. I mean, is the envelope of the design is some of the first consideration the architects applies to a building.
That makes sense. And now a question that's probably more towards Jens, but is it possible to hear more about the DGP and how this can be tested in the daylight visualizer?
I think I think actually that's Nicholas, because this is a feature that we are looking into for the future revision of the data visualizer. Yeah. But Nicholas, the DGP, what you can say, the DGP within the standard for the shading devices on the market, you will be more or less be able to use the tables that is added in the annexes. So that's for that. But for very special design, it will be a challenge, and then you need to calculate by yourself. But Nicholas, will you tell us more about that?
Yeah, I mean, for a quite detailed DGP evaluation and simulation tool, you want to make some fisheye view simulation with the Luminance, and to basically filter that with a tool called EvalGlare. It can also work from HDR images you record in real life, but basically the fisheye is important in order to get a sense of what is the different luminous source in your field of view, and then to detect what is the intensity of these sources and their distance from your kind of a central focal activity. So there's a lot of it's a lot of information which is used in order to detect the glare situation. And Jens, maybe you can correct me, but how do you evaluate this on an annual level?
Oh, I think the only way to evaluate it on an annual level is using the EvalGlare and a lot of calculation. And I know that one of the main author of the DGP have spent many hours on this. So that's why we pre-calculated the DGP for a lot of seating positions and view positions and shading and different shading types in the data standard itself.
Mm-hmm. So I guess it's possible to hear that the glare issue is definitely an ongoing one in the field of daylight simulation and practice. In terms of daylight visualizer, we would like to add support, say, to create these fisheye views and give this basically this indicator as one of the tools you can use to evaluate your design. But that will be for future version.
Great, thank you. And that was definitely a very good question. So thank you to the individual who chipped in with that. Another question here about the visualizer software. But what are the main steps to prepare the geometry before you import it into the program?
You basically it depends on which software you're using, but if you're, for example, in Revit, the geometry is pretty much ready. You want to include, say, the external obstruction in order to make your daylight simulation valid. and then you will export the model to DWG. You need to use the British layer assignment in the export routine, and you need to use local coordinates. The important thing to remember. If you work from the other CAD software and export to OBJ, then usually you have a choice to select. You want to link the material assignment or your layer assignment to kind of structure your OBJ file. So you do that accordingly. If you're in AutoCAD, like classic AutoCAD, drafting AutoCAD, then the layer assignment will be the one used to define the material elements. So what is a floor, what is a walls, and so on. And finally, if you use SketchUp, it will be the material assignment from SketchUp, which will be transferred to Daylight Visualizer. And in that case, you just need to be careful about the fact that SketchUp can give two different material to the same polygon. So that can be a source of problems. And these are the important steps to think about. You want to classify the materials in a simple way to what is relevant for your daylight simulation that will fasten the process. And the abstraction can be represented with simple geometry, whereas to import complex trees with thousands and thousands of polygons.
Perfect, thank you. Now, one of the questions that I haven't picked up yet was about whether this session will be recorded, which is a very good question rather, because this session has been full of loads of great advice that I'm sure people would like access to. And the answer to that is yes, we're recording this right now, and this recording will be available in the next couple of days. You should be able to find it via the World Green Building Council's social media channels, or via VELUX as well. So just keep an eye on Twitter, keep an eye on the websites. If you follow any of the hashtags you can see on screen, you should be able to be alerted when this recording is available. And one last question, a final pre-submitted one before we wrap up for today. But for Jens and Nicholas, who would you recommend should be using this software?
I would recommend. I mean, we make it very accessible and user friendly. So it's really for every architect who wants to work with daylight and to use it as a material in their project. But it becomes increasingly needed to actually verify, what are the daylight performance of your building. So I would see architects and engineers is definitely the target group, and it's very much used as well in education because again it's quite intuitive to use and at the same time quite robust. So it can be used to evaluate any kind of projects. It's not linked to only project with VELUX Windows. So it's one of the things we wanted to give a user-friendly, accessible, but very robust tool with this program. And I think there's also opportunity to use in other segment of the building industry, like house builder and project developers, maybe through consultant at that time, but it also makes sense.
And just adding that, I think some of the things is that, for example, among the municipalities in Denmark, some might actually use it too. So that could be that this is also the case in other countries too, around in Europe at least.
Perfect. Well, I'm sure we can all agree that the Daylight Visualizer seems like a really great software. So thank you both so much for taking the time to show us that and talk us through all these questions, and for your great presentations, Nicholas and Jens.
You're welcome. Thanks for the opportunity.
Thank you.
Thank you. And thank you to all of you who've attended this session. I hope you found it a valuable and enjoyable session. And as I said, the recording will be available soon. Before you go, we have a number of webinars happening throughout the rest of World Green Building Week. I'm running a webinar around certification tomorrow, And I will also be running a session around smart, nearly zero energy buildings on Friday. So you can find more information about both of these and register through the World Green Building Council website and also our social media channels. So thank you all very much once again, and have a great day.